Good evening. Good evening to everybody. Some work is going on, that's why I delayed. Okay? You ready with your instrument box and unrolled book, right? We'll have a class. Are you hearing some voice? Can you all hear me? No problem. Yes, good evening to everybody. Okay. Geometrical construction chapter. Geometrical constructions. Start with new unrolled book so that we can continue later all the geometrical portions in that book. Okay? Construction number, under that heading you take construction number 1. To divide a line segment in the given ratio. In the given ratio. Okay? Yes, that is the reason till 5 o'clock I waited. Some work is going on. Whatever I want to tell you, I will show you that on the board. Okay, please adjust for 10 minutes. Okay, try to adjust. First question, I will write the question here. Draw a line segment AB 5.6 centimeter and divide it the ratio 2:3. The ratio is 2:3. The first step is draw a line segment 5.6 centimeter. Okay? Shall I do construction here? Or is it visible here? Draw a line segment AB 5.6 centimeter. Draw a line segment AB of measurement 5.6 centimeter. Now make acute angle. This is how we do the acute angle. Make any acute angle like this. Acute angle BAX. Draw a line segment, make an acute angle. Okay, have you all done? Line segment 5.6 centimeter. Then construct an acute angle BAX. Okay. Now, using your compass, see the ratio. Ratio is 2:3. Sum of the ratio is 2 plus 3, 5 parts. So, divide the ray AX into 5 equal parts. Now here, using your compass, divide the ray into 5 equal parts. A1, A2, A3, A4, A5. Name it as A1, A2, A3, A4, A5. Are you all doing? Okay. Now join A5 to B. Join A5 to B. Join A5 to B. Okay. Is it clear? Now just to see, we need the construction of the corresponding angles. How to do? Now with A5 part, or you all see, from here with convenient radius, draw an arc. Since it is 2 to 3, keep the point here, draw the same arc here. From A5 arc, from A2 arc. Okay? Now take this width. From here you take this width. From here to here. Cut off base. Same here also you cut off. Okay? Now passing through the intersected arc, you just join A3, A2, let it intersect AB at point P. Now, AP is to PB equals 2:3. I will explain once again. Draw a line segment. AB equals 5.6 centimeter. Make any acute angle BAX. Since the ratio is 2:3, sum of the ratio is 5. So divide the ray AX into 5 equal parts. After cutting off 5 equal parts, join A5 to B. Now with convenient radius in your compass, draw an arc like this. Okay? Same arc from A2 you have to draw. Same arc. Now take this width. Take the width from here to here and cut off the edge of this arc here. Now join, and you can verify your construction by just sliding here. You will get a line which is parallel to AFB, which divides the line segment AB in the ratio 2:3. This verification you are going to understand when you do the similar triangles. When a line is drawn parallel, it divides the two segments or the sides of the triangle in the same ratio. Since it is dividing here 2:3, so AB is to PB is also 2:3. Is clear? Is it clear to everybody? So we call this construction number 1 line bisection, that is to divide a line segment in the given ratio. Is it clear? Divide a line segment in the given ratio. Is it clear to everybody? What assignment sheet I sent, that is there you have different question. I am giving different questions here. Some questions you may get repeated also, but number of questions so that you can increase from the class and also the worksheet. Shall I move on to the next question now? Say yes or no. What a myth. Can I move on to the next question? Next question. Question number 2. Draw a line segment. Draw a line segment PQ equals 10 centimeter. Divide it in the ratio 3:5. Divided in the ratio 3:5. That means the sum of ratio is 8. You have to divide it into 8 equal parts. We'll do now. First step is draw a line segment PQ. Can you see? Draw a line segment PQ of length 10 centimeter. Name the segment and write up the measurement. Next step is, what is the next step? Make any acute angle. Make any acute angle. Name it as QPX. Since the ratio is 3:5, sum of the ratio will be 3 plus 5 equals 8. Sum of the ratio is 8. So we have to divide the ray PX into 8 equal parts. Shall we do? So with the convenient radius in the compass, divide the ray PX into P1, P2, P3, P4, 5 will be elongated more, so I will reduce the width of the arc so that within the segment you can get it. Okay? I will avoid of stretching of the construction part. So now take your convenient radius, name it as P1, P2, P3, 4, 5, 6, 7, 8. You can extend any width if you want elongated wide construction. You can take the compass width wider. Okay, na? But all the cutting should be of same width. Now name it as P1, P2, P3, P4, P5, 6, 7, 8. After naming the parts, now join the last part to the base of the segment P8Q. Is it clear? After cutting off the sum of the ratio, now P1, P2, P3, P4 like that P8, join P8 to Q. After joining, now we have to draw the line parallel. 3:5, so you should draw a line from P8 to Q parallel to this. So what you have to do? Make a convenient radius, any width, cut off this arc like this. Say at P3, taking the point at P3, draw same width arc. Now take this width. This width you have to cut off here. Okay, na? This width you have to cut off this, so that we are making corresponding angles. When the corresponding angles are equal, the line must be parallel, converse of corresponding angle theorem. So now passing through P3, draw a line which is parallel intersecting PQ at M. So PM is to MQ equals 3:5. 1, 2, 3, 1, 2, 3, 4, 5. So 3:5. Is clear? Do the construction neatly. I will show you how to construct the corresponding angle with convenient radius. Keep the compass point like this. Draw an arc line. Same arc from P3 you have to draw. Take this width. Cut off this width here also. Okay, na? Passing through that, you draw a line that will be parallel. You can also verify the line which is it parallel. Just proceed this point like this. You will get a line parallel, so your construction is right. Is it clear? Okay. So now using these two type of construction, in worksheet I have given two more questions. You can answer as an assignment work. Okay. If possible, use these questions also. Now I will move on to the next type of construction. Is it clear to everybody? The construction, that is construct line bisection to a given line segment in the given ratio. Shall I proceed now? Next question. Is it clear? Next question. Next heading. Tangent. So construction of tangent. Before doing construction of similar triangles, I am moving with this construction of tangent. So before doing the construction of tangent, that tangent word you will get it when the circle chapter, tangent to a circle you will get. Since we have not yet started, here I will explain the tangent, how a tangent differ from a chord and a secant. You have heard the word secant. So, this is a circle with center O. Okay, na? Now, if I draw a line segment taking 2 points on the circle, what we call this? What we call this? It is a chord. Okay. Suppose if I draw a line segment intersecting the circle in 2 distinct points, it is secant. It is a secant. Now, I will draw another line where it is touching the circle exactly at one point. Then this line is called tangent. So tangent is a line which touches the circle at exactly at one point. A secant is a line which intersects the circle in 2 distinct points. A chord is a line segment which has 2 fixed points on the circumference of a circle. It has 2 fixed points. It is intersecting. It has only 1 point of intersection. Exactly, it touches the circle at 1 point. Got the difference? Now, making use of these properties, we have few more construction. The first property of the tangent is tangent drawn to the circle is perpendicular to the radius. So making use of that, we are constructing a tangent to a circle. That means if I draw a circle taking any radius, if I draw a circle like this, okay, it's not listening now. And if you construct a tangent to it, this tangent is always perpendicular from the radius drawn from the center. So tangent is perpendicular, radius is perpendicular, it is perpendicular. So using this property, we construct a tangent to a circle. Okay, so let us do this. Then to move the second type of construction, a pair of tangent. Again I will explain another property of the tangent. Again we recall, a tangent is a line which intersects the circle exactly at one point. So tangent drawn at the point is perpendicular to the radius drawn from the center, that is OP is perpendicular to PT. that we are going to prove as a theorem in circle chapter. Now based on that, now the construction of the tangent. So now take down the question. Question number 3. Draw a circle of radius. Draw a circle of radius 3.5 centimeter. Construct a tangent. Construct a tangent to a circle at point P. Take the question. Draw a circle of radius 3.5 centimeter and construct a tangent to a circle at a point P. Now use your compass. Draw a circle of radius 3.5 centimeter in your unruled notebook. I hope everybody is having unruled book. So take the unruled book, draw a circle of radius 3.5 centimeter. Get its center O. Have you all drawn? You all drawn? Now take a point P. Anywhere on the circumference of a circle you can take. I have taken here P. Now after taking the point P, join O to P. So take a point P and join O to P. Have you all doing the construction? First you should draw a circle of radius 3.5 centimeter with center O. Take a point P on it, anywhere on the circumference. Join O to P. Now see how we are going to get the tangent by constructing the perpendicular. You have learned how to construct a perpendicular line. 90-degree construction. Here you have to do taking convenient radius from here, draw an arc. What are you doing? Take a convenient radius, draw an arc. From here, cut it 60 degree. 60 degree, further bisect, it will be 30 degree. So 60 plus 30, it is 90, so that we get a tangent like this. T dash. T dash or T dash T is the required tangent to a circle with center O at a point P. So we constructed this based on this property. Tangent drawn at the point of contact is perpendicular to the radius drawn. Conversely, if a line is perpendicular to the radius drawn, that line must be a tangent. Okay, na? If it is a tangent, it must be perpendicular. If it is a perpendicular, it must be a tangent. So based on this property, we constructed this. Okay, na? Shall I move on to the next question? No answer today. You are all busy with construction, I don't know. No response. So here onwards no question, only I'll just goes on answering, doing the work. You can just copy it without any sharing of the doubts. Shall we do like that? Okay. Next, take the next question. Draw a circle of radius. Next question. Draw a circle of radius 4.2 centimeter. 4.2 centimeter. Draw tangents. Instead of draw, I will mention the word construct tangents at the end of diameter. At the end of diameter. Okay. So first, as usual, you have to draw a circle of radius 4.2 centimeter using your compass. Here comes a circle. Okay, we have drawn a circle of radius. Drawn a circle of radius 4.2 centimeter. Now draw a diameter like this. Name this diameter as AB. The question is, you have to construct tangents at the end of the diameter. Okay. So now what construction you do, you have done in this OP like that. Here also at both the end you have to construct the 90-degree line. 90-degree perpendicular line you have to construct it like this, with this 60-degree, further 60-degree, bisecting, it will be 30-degree. Okay, so now name it as PQ. It is touching it at a point, exactly at a point. A point we are constructing. Okay. Next, at B also do the same thing. Taking the convenient radius, construct a perpendicular line perpendicular to the radius from the center. emitters RS. Are they are parallel? If they are parallel, how we are going to prove in the tangent to a circle chapter? Prove that tangent drawn at extremities of the diameter are parallel. Here we constructed, since 90 degree, 90 degree, the co-interior angle supplementary, or we can take alternate interior angles are equal, the line must be parallel. What theoretically we are going to prove, that is showing here in the practical way. Is it clear? Next question. Shall I move on to the next question? Okay. Now I do the construction of pair of tangents to a circle from an external point. Here comes one of the property, tangents drawn from external point to a circle are equal in length. So when we consider external point, from there if you construct a tangent and measure it, you will get same measurement from both the tangents. This is also one of the property of the tangents. Tangents drawn from external point to a circle are equal in length. Okay, na? Now based on that, take the question. The same type you will have in the worksheet also. Now draw a circle of radius 3 centimeter. Take a point P at a distance 8 centimeter from the center. Now construct a pair of tangents. A pair of tangents. Okay, na? I will repeat the question. Draw a circle of radius 3 centimeter. Take a point P at a distance of 8 centimeter from the center. Now construct a pair of tangents to it. Okay, na? Check out the question. Here comes the construction. First step is draw a circle of radius 3 centimeter using compass. This is the center with the radius 3 centimeter. Now from the center take 8 centimeter away from the center a point P. So after constructing or drawing a circle using scale, take a distance of 8 centimeter from the center and join OP. The length of the OP is 8 centimeter. Constructed. Okay, na? Next, draw the perpendicular bisector to OP. You know, in 9th standard itself, construction of perpendicular bisector. How to draw construct by perpendicular bisector? Taking more than half, draw arc on both the side with the same radius. Cut off the former arc. I'll show you with convenient radius. Taking more than half of OP, draw arcs on both the side with same radius. Cut off the former arc from both the side. But these arcs should be a very light mark, because we have to highlight the main tangent construction. Now join this perpendicular bisector with a dotted line like this. It is a perpendicular bisector to OP, intersecting OP at point M. So this is the first construction in the textbook. The previous construction as a base I have given, it is an application. Construction of a pair of tangent is in your syllabus. Construction of a tangent is not in your syllabus, but still sometime you may get the question like this. So I included that question first, because both are under the property and the theorem, so it is better to learn both type of construction. So after joining O to P, we have constructed the perpendicular line. Have you all constructed? No answer. Have you all understood? No answer. Okay? So after this, now with O as M as center, MO as radius, draw a dotted circle which intersects the given circle in two distinct points. We are drawing dotted circle. Okay? That circle is intersecting the given circle in two distinct points. Which are those points? Here you name it as A, this is B. What we have drawn with M as center, MO or MP as radius, cutting the given circle at A and B. Now join PA. Now join PA and PB. Now measure it. And mention the measurement. Did you measure? You have to get in and around PA equals PB equals 7.4 centimeter. 0.1 or 2 difference is okay. If you get 7.3, 7.5 is okay, but not less than, not more than this 7.5 or 7.3. Okay? Have you all got the measurement? And both the measurement should be equal. Write the measurement below the construction or side of the construction like this. Have you all constructed? Okay. Shall I move on to the next question? Okay. Next question. Draw a circle of radius 4 centimeter. Take 2 points P and Q on one of the extended diameter. Extended diameter. Now draw pair of tangents from the points P and Q. Take 2 points on one of the extended diameter at a distance 7 centimeter. Now take the question completely and show the construction method. Over. Now we'll do the first part. Draw a circle of radius 4 centimeter. Come on. Draw a circle of radius 4 centimeter using your compass. Draw a circle of radius 4 centimeter. So passing through the point O, extend the diameter in either side which are at a distance of 7 centimeter. This is point O, P and Q, 7 centimeter, 7 centimeter. First, draw a circle of radius 4 centimeter Take points P and Q, one of its extended diameter, such that OP equals OQ equals 7 centimeter. Up to this over. Now consider P as an external point. Like previous construction, draw pair of tangents. Q as another external point and construct a pair of tangent from the point Q also. Okay? Yes. Now draw the perpendicular bisector to it like this. Okay, taking more than half, cutting on both sides, from both center, cutting off the former arc. Now join this intersected arcs by a dotted line like this. It is intersecting OP at M. Can you see? It is intersecting OP at M. Now with M as center, MP as radius, draw a dotted circle like this, intersecting the given circle in two distinct points. So you have to tighten up your compass, otherwise it won't follow you. A and B join PA like this, PB. One part over. Same procedure you take it for the second point to Q. That is, construct the perpendicular bisector to OQ, taking more than half, cutting on both the sides with the same radius. From here, cut off the former arc. That is, the first part is to construction of the perpendicular bisector. Draw the perpendicular line. Okay. Now you get an intersected point at N. Now with N as center, ON as radius, draw another dotted circle. So you get accurately in your book, and on the board with this compass problem I may get a little bit difference in the distance. And taking the dotted circle so that we can highlight the tangent part. C, D. We got another intersecting points. Join QC, join QD. So while joining, it should exactly touch the circle at one point only. Be careful while joining it. Now measure PA equals PB, QC equals QD. You must get same measurement. What measurement? 49 minus 16 is 35. Root 33. So you must get approximately 5.7 centimeter. Check your answer. 5.7 centimeter. This is how we construct the pair of tangents from the extended diameter to the given circle. So for each construction, steps of construction is must. I am slowly explaining those statements. You have to take it as a steps of construction. Okay, now here we got the application of pair of tangents, construction of pair of tangents from an external point to a given circle. I'll give one more question. If you all completed this, we'll do one more question. Construction of pair of tangents. Over. Have you all completed? Okay. I'll give one more question. Have you all got 5.7 centimeter? So we'll move on to the next question. Draw a circle of radius 2.5 centimeter and construct a pair of tangents at a point P 7 centimeter from the center. 7 centimeter from the center. Okay. So now let us draw a pair of tangents to a circle of radius 2.5 centimeter. First, draw a circle of radius 2.5 centimeter, very small circle, and should be at a distance of 7 centimeter from the center. Take a point P from the center, 7.7 centimeter. And you know how to construct the perpendicular bisector. So construct the perpendicular bisector to this. It is with O as center, radius equal to more than half. Draw arcs on both the sides with same radius cut off the formula like this. Okay. Now join the intersecting arcs. You will get point of intersection as M. So instead of putting or constructing the dotted circle, we can also make an arc to the circle. That is another method. I will show you that here. With M as center, OM as radius. Instead of dotted circle, just make one arc like this. Okay? Either you can do dotted circle or just make an arc like this. Okay? And name those 2 points as M and N. M and N join PA and PB and measure it. What you get? Did you measure? What is the measurement? You should get PM equals PN 6.7 centimeter approximately. You measure using scale 6.53 or 6.5 centimeter. If you measure, how to measure the tangents? From this point, both tangents at point M and N should be of equal length. It is satisfying tangents drawn from external point to a circle are equal in length. Is it clear? So instead of like dotted circle, here I have shown the alternate method. Cut off MO radius at M and N is already M is there. So you can take this point as A. Okay. Then if you measure, you will get a pair of tangents which are equal in length. So similar types of questions, it is in the worksheet. Try to construct those along with the steps of construction. The remaining types of question I will show you in the next class. Is it clear? Okay. Have you all done this construction now? Repeat it. Again, do the question which is on the worksheet also. You will get practice. And don't forget to write up the steps of construction and the measurement what is required, naming of the figure, everything should be in detail. Okay, na? Later in the next class I will show you how we can actual calculation, how we can verify also. Try to verify with the actual calculation. We will do that in the next class. Thank you, children. Today, without any answering part, you have completed your class. I am very happy. Okay. So that no class will be now questionnaire class. Only one way of teaching is better for me. Thank you, children. We'll see in the next class with the same type of questions.